So to create an equation in slope-intercept form, you need two things. You need the slope and you need the y-intercept. So if you want a reminder, slope-intercept form is y equals mx plus b. You will need to memorize this for our next quiz on Tuesday so that you know how to insert the numbers into the formula. We can find an equation of a line from a graph, from 2 points, or from a table. So we skipped these two problems below when we first did this. We skipped letter C and D because at that point we only knew how to create an equation of a line when the slope can be found but the y-intercept was given. In letter C and letter D, these two graphs give two different points, none of which are the actual y-intercept. So what I'm going to do now is show you how you can create an equation of a line when 2 points are given but not one of them is the y-intercept. So in order to find the slope, you're going to want to use the slope formula, which is y2 minus y1 over x2 minus x1. This is the slope formula. This is a formula that at this point you should probably have memorized because we've been using it so much. I have not decided if I'm going to be putting the formulas on the quiz or not yet. I haven't decided that. So if I were you, I would just start to memorize these things if you haven't already. I'm sure you have because of all the times I say it and all the times you've been using it. The formula looks like it's confusing. I know with the little 2's and 1's, but it's basically just take the two y numbers, subtract them, take the two x numbers, subtract them, and then divide, and that will be your slope. So the two points that are given are negative 3, 3, and 3, negative 1. Then this is the first x, that's the first y. This is the second x, and this is the second y. So in order to find the slope, we're going to take y2 and subtract y1. So that's going to be negative 1 minus 3. And we're going to divide that by x2 minus x1, which is 3 minus negative 3. Then we simplify these two little subtraction problems, and our answer will then be a fraction. Negative 1 minus 3 is negative 4. 3 minus negative 3 is really 3 plus 3, which is 6. And since negative 4, 6 can be simplified, you're going to want to do that. We can divide this by 2 and this by 2. This simplifies to be negative 2/3. So the slope of my equation is negative 2/3. In previous problems, once you had the slope, once you found it, then all you needed to do was take the slope, put it in for m, and then look for where it crosses the y-axis, and then put that number in for b. Now, looking at the graph, the point that they give you does not specify what this number is. Now, if you look closely, it kind of looks like it's almost perfectly at 1 on the y-axis, at 0, 1. But whenever you're given a graph and you're not positive what the actual number is, I want to show you how you solve for it. So I'm not going to say that it's actually definitely 1 because sometimes it might not be, and sometimes you might see that it looks like it's in between like 1 and 2 or 2 and 3, and you can't just estimate it if it's not perfect to be like, oh, it looks like it's 1.5. Your equations always have to be accurate. So if you have a problem like this and you're not sure what the y-intercept is, since they don't give it to you formally in the problem, you're going to first put in your slope into the formula. Y equals negative 2/3 x, and then just put plus b because that's what the formula usually says. And what we're going to do is we're going to pick a point, and we're going to replace that number, those numbers for x and y, in for the x and y in the problem. So you can choose either one of these 2 points. Whichever point you like better, it doesn't matter. You can always choose the first one. You can always choose the second one. You can choose the one that has the least amount of negative numbers if you like positives better. You can pick the point that doesn't have any fractions or decimals if there was one that had one and the other one didn't. In this case, both of these ordered pairs have negatives. They both look equally difficult. I'm just going to choose the first one, and because this is an x number and because this is a y number, what I'm going to do is replace negative 3 in for x into the formula here. So I'm going to replace negative 3 in here, and I'm going to replace positive 3 in for y here. And I'm doing that to solve for what the y-intercept is. So when I substitute these numbers in, instead of it saying y equals, and I'm running out of room, so I'm going to rewrite the rest of it up here, it's going to say 3 equals negative 2/3. Usually it would say times x, but I'm replacing in the x value, which is negative 3, and then finishing the equation plus b. What I did here was I replaced in the ordered pair negative 3, 3 in for x and y in the formula. I did that because negative 3, 3, this point up here, is a solution to this line. So if I replace the point in for x and y into their places that they should go, and I'm left with this here, this variable, I could now solve for the variable b to figure out where it crosses the y-axis. So what I would do here is multiply negative 2/3 times negative 3. Well, a negative times a negative is a positive, and negative 2/3 times negative 3 would be a positive 6/3, which will equal 2. So this thing right here will all equal positive 2, so we're left with 3 equals 2 plus b. And then to solve for b, what's the last thing I would do? I have 3 equals 2 plus b. What would I do to solve for b? What would I do to move the 2 out of the way? Add, subtract, multiply, or divide? Subtract. Yep, I'm going to subtract both sides by 2. 3 minus 2 is 1, so we get that b, which is the y-intercept, is indeed 1. Now, looking at this, I could kind of tell that it looked like it perfectly went through the y-axis at 1, but not all of the time will it be that way. Sometimes it will be a fraction, and you have to solve for it. So then altogether, we have what the slope is. We know now that b is equal to 1, which is our y-intercept. So the final equation would be y equals negative 2/3 x plus 1. What we did here was we first took the 2 points and we found the slope of those 2 points. After we found the slope, we put that into the formula, but we did not know what the y-intercept was because they did not give us that point for the y-intercept. We picked one of the points and then we replaced those numbers in for x and y into our formula, and then we solved for what the value of the y-intercept would be using like regular algebraic inverse operations. Once we found that b was equal to 1, then I can put the 1 in for the b spot and be confident that the y-intercept is actually 1 and not just use what my eyes think it would be, because sometimes it might not be perfect. We're going to do the same type of thing again with the next one. I'm just going to erase everything so I have more space. Now notice for A and B, these graphs here, they gave us the y-intercept. So once I found the slope, I knew this y-intercept was negative 1 because they gave me the point that has 0 in for x. I knew the y-intercept for this one was 2 because they gave me the point that says 0 is here for x, which means the y-intercept is 2. Letter D does not give us that. So when I look to solve this problem here, and I go to find the equation of the 2 points here of this line, I would first find the slope, and then when I look for the y-intercept, it looks like it's at negative 2, but we have to verify that with algebra. So step 1, let's take these 2 points and use the slope formula to find the slope. So we're going to be using 2, negative 1, and 4, 0 to find the slope. The slope formula says take 0, subtract negative 1, divide that by 4 minus 2. Well, 0 minus negative 1 is 0 plus 1, which equals 1, and 4 minus 2 equals 2. So my slope here is 1/2. Now, if they gave us the y-intercept, our equation would be done. It would be y equals 1/2 x, and then plus or minus whatever the y-intercept is. In this case, it looks pretty close, like it's going to be negative 2. Yes? Sure. So if I was looking at these tick marks, this is negative 1, this is negative 2, it does look like it crosses the y-axis at negative 2. But we have to verify that with algebra. So you pick a point. Looking at the 2 points to choose from, I kind of like the second one better because all the numbers are like positive. 1 is 0, so that makes it pretty easy. So what I'm going to do is use the point 4, 0, and I'm replacing 4 in for x and 0 in for y to solve for what b is equal to. When I do that, this equation turns into 0 equals 1/2 times 4, and then plus b. Then I used algebra to solve for what b is equal to. 1/2 times 4 is equal to 2, so I'll write the rest of this up here. This is going to be 0 is equal to 2 plus b. And then to solve for b, I'm going to subtract both sides by 2. 0 minus 2 is -2. And I can verify that the y-intercept is at -2. So I have here that the y-intercept is -2. I have my slope as 1/2. So putting everything together then in slope-intercept form, my final equation would be y equals 1/2 x minus 2. So when you're finding equations of lines, you always need two things, the slope and the y-intercept. The easier types of problems will give you 2 points, either in graph form or just 2 points, and say create the equation. And one of those 2 points will be the y-intercept. Sometimes the y-intercept is not given, and you actually have to find the slope of the 2 points by doing what I just did here, by substituting numbers in. So if you actually look at the page after this page, on page 16 here, we already did, oh sorry, the page before, not page 16, page 14. So if you flip to the page before, we did our own problem here, and we skipped this problem because I said we were not ready for this just yet. So if you look at page 14, which is the page in front of what we just did, you see a bunch of work here. You should see a bunch of work here with a different problem because I actually said we're not ready for this problem yet. But now we are. So the example here says write the equation of the line that passes through these 2 points. Now looking at these 2 points, the first thing you would have to do is use the slope formula to find the slope. So if you look at step 1, you can see that the slope formula was used. They did 8 minus 7 on the top, since this is y2 and this is y1. And on the bottom, they did -2 minus 3. Then you can see the simplification process. 8 minus 7 is 1. -2 minus 3 is -5. So they simplified this to be -1/5. Or I would probably put the negative with the 1 like that. Now here's where things get tricky. So on the left-hand side, you might have some room still. I'm going to kind of copy what goes on here. What happens here, once you have your slope, your equation turns into y equals -1/5 x, and then plus whatever the y-intercept is. The y-intercept is not given. So if you notice, there is no y-intercept given in these 2 points. How can I tell that there's no y-intercept given in this problem? When you have a y-intercept in point form, what do you always see in the x spot? Anyone? It's a number. Whenever you're on the y-axis, what is x equal to? 0. So because there's no 0 in the x spot, and this is a 3, and this is a -2, and they're not 0, I know the y-intercept is not given. So what I have to do is pick a point. They chose to pick the point 3, 7, which I actually would probably prefer to pick that point 2 because they're all positive numbers. So they choose 3, 7. I'm going to choose 3, 7 as well. And what you do is you replace in 3 for x up top and 7 for y up top. So instead of it saying y equals, we're going to be using 7 equals. And then this is going to be -1/5 times 3 plus b. So now once we have this, we're just using algebra to solve for b. -1/5 times 3 is going to be -3/5. And you can just use your calculator for this. To solve this equation for b, I would add 3/5 to both sides. When I do that, I'm going to get that b, the y-intercept, is equal to 7 plus 3/5 is just 7 3/5. It's okay that this is in the mixed number because this is a y-intercept. Slopes cannot be in mixed number form, but it's okay that the y-intercept is. So then once you have your slope and you have your y-intercept, then you can see that they put everything back into the formula. Y equals -1/5 x plus 7 3/5. Notice this y-intercept is something we've never seen before. So this line, where the line crosses the points for 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, would be about here. And then -2, 8 would be about, oh, that's a little too high, be about here. If we were looking at this line, mine looks actually like it's kind of accurate. But if it was an accurate line, you would not know where the y-intercept was because it's a little bit above 7. It's 7 3/5. So when you're given a graph or you're given 2 points and the y-intercept is not given to you, you have to solve it by using this method here. All of the practice problems that you worked on yesterday, the slope was either given or could be found, but the y-intercept was given in every single problem that I assigned. There wasn't any problems that I assigned that you did not have those because we just didn't learn that yet. So what we're going to do quickly is just a couple practice problems. If you could please turn to page 19. So on page 19, the practice problems look very similar to the problems you worked on yesterday. Looking at exercises 13 through 18, they want us to write an equation of the line that passes through these points. Now, if you look at these problems, every single one of these problems I would consider easy because every single one of these problems gives you the y-intercept. For number 13, the y-intercept is -4. I can tell that because this 0 is here, which means this is the y-intercept. For number 14, the y-intercept is -7. I can see that because this is 0, which means this is the y-intercept. Number 15, the y-intercept is 2. Whenever you look at 2 points and you can see that the y-intercept is given, then that problem would be easy to create an equation of a line. So what I'm going to do is actually change 2 of them and have you do the rest. So I'm going to change numbers 14 and 15. So we're going to cross these points off, and I'm going to create 2 different points so you can see the differences between these problems. So for 14 and 15, I'm just going to choose 2 random points. I'm going to choose 2, 4, and I'm going to choose 6, 10. So you're going to find the equation of the line that passes through these 2 points. And then for number 15, I'm going to choose 2 different points, and I'm going to use, let's say, -4, 6, and I don't know. Trying to keep even numbers so everything's nice and easy. 8 and 12. So what I want you to do right now is practice what we just learned with numbers 13, 14, and 15. Number 13 is the easier type of problem because when you go to find the slope and y-intercept of 13, once you find the slope, you're basically done because the y-intercept is given. But number 14 and 15, we changed the points, which then changes the whole problem. Now, not only do you have to find the slope, but you have to find the y-intercept as well. So go ahead, take a few minutes, do 13, 14, and 15, and then stop. Then we'll go over the answers together. whole thing. So slope and line. All right, so let's go over these answers. If you didn't get that far to get all three done, just make sure that you write in everything that I'm writing up here as well. So for number 13, 14, and 15, we're creating an equation in slope-intercept form, y equals mx plus b form. To do that, we will have to use the slope formula each time to find the slope. And then depending on the point given, you might either have to find the y-intercept or maybe the y-intercept is given. If the y-intercept is given, it's easy. You just find the slope and you're done. You put it right into the formula. If the y-intercept is not given, then after you find the slope, you also have to find the y-intercept and then put it into the formula. Number 13 is the easier out of these three problems because the y-intercept is given. I know that this is the y-intercept because every point that is on the y-axis has 0 in for the x number. So because this point 0, -4 is given, I don't have to find the y-intercept. I know I can just put -4 at the end of the formula and it's done. But I do need to find the slope. So to find the slope, I would do 4 minus -4 over 8 minus 0. 4 minus -4 is really 4 plus 4, which is 8. 8 minus 0 is 8. 8 over 8 simplifies to be 1. So I have my slope. I put it into the formula, y equals 1x. And then my y-intercept is -4, so I would put -4 at the end, and that is my equation. I am done. This one is easy because the y-intercept was given. I changed the points for 14 and 15 specifically so that the y-intercept was not given to give you some practice trying to find it. So for number 14, when I go to find the slope, I would do 10 minus 4 over 6 minus 2. 10 minus 4 is 6. 6 minus 2 is 4. 6 over 4 simplifies to be 3 over 2. So that is my slope of the line. When I go to put this in the formula, I quickly realize that I don't have the y-intercept. My equation cannot be completed. I'm just going to use the space below here to finish the rest of this problem. But I cannot complete this equation because the y-intercept is not given. In order for the y-intercept to be given, you have to see a 0 in the x part of the ordered pair. Because this number is 2 and this number is 6, I know that neither one of these points lies on the y-axis, so I cannot put one of those numbers in here for b. In order to find what the y-intercept is without graphing and then looking at what it looks like to be, I would use algebra. You pick a point. You can either use 2, 4 or 6, 10 to replace in for x and y, and then you would solve for b. I'm just going to use 2, 4 because that was the first one given. So what I'm going to do with that, looks like 214. What I'm going to do with this point, 2, 4, is replace 2 in for x and replace 4 in for y. So in this equation here, y equals 3/2 x plus b. I'm going to replace in a 4 for y, and I'm going to replace a 2 for x. Then I will solve for b. So to solve for b, I would first do 3 over 2 times 2. Well, 3/2 times 2 just equals 3. So I get 4 equals 3 plus b. If I'm trying to solve for b, that means I'm trying to solve for the y-intercept. To do that in this case, I would subtract by 3, and 4 minus 3 is 1. So I get that b is equal to 1. Now I have what I need. My slope I know is 3/2. I found that in the beginning. I now found that my y-intercept, which is what the b value represents, my y-intercept is 1. So altogether, I can then finalize this equation to be what? Y equals, what would this equation be? Y equals, what's my slope?
3 over 2.
3 over 2, so 3 over 2x, and then what's my y-intercept? 1, so plus 1. So here's my final answer. I'm just going to circle it in green so that you can see. My equation is y equals 3 over 2x plus 1. My slope I found in the very beginning to be 3 over 2, and then I just found what the y-intercept was, which is 1. The same process will happen in number 15, which I changed those numbers. The first thing you would do is find the slope. So to find the slope, I would do 12 minus 6 over 8 minus -4. 12 minus 6 is 6. 8 minus -4 is 8 plus 4, which is 12. And 6 over 12 simplifies to be 1/2. So I have my slope. If this problem was easy, I would have my equation because one of the points that was given was the y-intercept. But as I look at these points up here, neither one of these represent the y-intercept. This one's not on the y-axis, this point's not on the y-axis. So I'm stuck. Whenever I'm stuck, I create the equation for what I have so far. I know my equation is y equals 1/2 x, but then I don't know what the y-intercept is, so I just finish out the equation by putting plus b. Then what I do is I choose a point. I can either use -4, 6 or 8, 12, and I replace those numbers in for x and y. Looking at these 2 points to choose from, I would most likely want to go with this one just because everything is positive. So I'm going to be using 8, 12. And when I use 8, 12, I'm going to be replacing 8 in for x and 12 in for y. So instead of it saying y equals 1/2 x plus b, it's going to say 12 equals, and instead of it saying 1/2 x, it's going to say 1/2 times 8, and then plus b. Then what I do is I solve for b. 1/2 times 8 is 4, so it's going to be 12 equals 4 plus b. I solve for b by subtracting by 4. 12 minus 4 is 8, so I get 8 is equal to b. Now that I have that, b represents your y-intercept in the formula, so I know that my y-intercept is 8. I have my slope, I have my y-intercept, so now it's time for me to just put it into slope-intercept form, which would be y equals, my slope is 1/2, so it's 1/2 x. My y-intercept is 8, so it's going to be plus 8. That's my final answer. These last two problems were more difficult because these last two problems required us to find not only the slope, but we also had to find the y-intercept since it was not given.